So welcome to this video. We have a question on Newton's laws of motion under introductory physics. Assume the three blocks portrayed in figure this one move on a frictionless surface and a 42 Newton force acts as shown on the 3 kilograms block. Determine the acceleration of the given system, the tension in the cord connecting the 3 kg and the 1 kilogram block, and the force exerted by the 1 kilogram block on the 2 kg block. All right. So, before we even go anywhere, let's first write the forces that are acting on these objects. One thing that you need to understand that there's tension here. Okay? So we can call that as tension, which is common, isn't it? And because this guy is going this side, means the acceleration is going in that direction. So, because 1 kg and 3 kg are connected together, meaning that tension there is common, all right? And it is acting in both directions, like that. All right, so if we want, since this is a system, they are connected, right? Since this is a what? A system, and they are connected, the acceleration is just given by the sum of forces, okay, over total mass. And the force here is actually 42 newtons, and the masses is 1 plus 2 plus 3, which give us 6, and this will give us 7.0 meters per second squared. All right, of course, to the right, horizontally. B says the tension in the cord connecting 3 kg and 1 kg. So 3 kg and 1 kg, you want to find this force there. So before we go anywhere, let's first find the forces that are acting on the 1 kilogram. So on the 1 kilogram, we only have the tension in that direction. Of course, we have the weight. But we are not interested in the weight because the acceleration is not vertically but horizontally. Then this is the 1 kilogram. Then when we get the 3 kilogram, all right, we also have got the weight. Let's call it weight 3. But there's also a force here, which is 42 newtons, which is T. Sorry, it's just F. And we have the tension here, all right? So if we want to, since they are saying it's this guy and this guy that are connected, and if we want to find tension, all right, meaning we can just say sum of forces in the x, all right, is just equal to mass multiplied by acceleration in the x. Okay, so which block do we focus on? We focus on the bigger one, because this guy here has got the force F, which is pushing the other side, also which is pulling, and also the tension also, which is also opposing the motion or in the opposite direction, meaning we focus on the 3 kilogram block. So here, sum of forces, the force here F is going in that direction, then the tension minus the tension is equal to max. So this will give us what? The F is 42 minus T is equal to mass is 3 kg, acceleration already found it was 7. So this will give us 42 minus T is equal to 21. 21, yes. So of course, 42 minus 21 is equal to tension. And what do you find as tension? Okay, so our tension now is just equal to what? 21 newtons. So where is it going? To the right, to the left. It's actually also going, oh sorry, the tension is just fine. I thought we were finding the acceleration. Sorry. All right, then C says what? C says what? The force exerted by the 1 kilogram on this friend of ours there. Now, one thing that you need to understand is that this acceleration that we found at the beginning, the 7 meters per second squared, right, is common for all the blocks. For all the blocks, meaning that the force which is accelerating the 2 kilogram, the force accelerating this guy, for this guy to move, right, the force which is moving this object is due to this. Do you understand? So the 1 kilogram is the one which is causing the 2 kilogram to move or to accelerate. You get the concept, right? And because of that, we are going to focus on the 2 kilogram. The mass will be the 2 kilogram because it's being moved by that one, meaning this is a force. So there's a force here causing this guy to move. And because there's a force causing this guy to move, it's like you have this. It's like you have the mass 2 kilogram, and there's a force here moving it. And we know that the force here, it will be equal to mass times what? Acceleration. So this force is due to the 1 kilogram, is due to this. So this guy is applying a force. Okay, this guy is applying a force on the 2 kilogram, causing it to move. So that's the force we are trying to find. which is mass 2, acceleration 7, to give us 14 meters per second. Okay? Squared. Of course, to the right, because this is where the motion of the system is going. Simple as that.